Welcome to another Algebra 1 video. This is Unit 1, Lesson Topic 8, Equations in Problem Solving. I'm Mr. Pilarski and I'm your math teacher. Our objectives today are, I will be able to define a variable in terms of another variable. I will be able to solve consecutive integer problems. And I will be able to solve uniform motion problems. Let's get this algebra party started. Here we're going to be talking about defining variables. In example 1t, defining one variable in terms of another. The width of a rectangle is 3 inches less than its length. The perimeter of the rectangle is 26 inches. What is the width of the rectangle? When you read this problem, you want to focus in on the actual question. This problem consists of 3 sentences. One sentence ends here, one sentence ends here, and the other sentence ends here. And if you look here, here's your question mark. This is what you're being asked to find. What is the width of the rectangle? So the first thing you might want to do is you might want to define a variable, and in this case, you'd say W is equal to the width. Now, in this first sentence, it says the width, right here, it says the width of a rectangle is 3 inches less than its length. The first sentence is where we define one variable in terms of another. We define the width in terms of the length. This sentence, the width is 3 inches less than its length, can be interpreted as this equation. The width is, now right here, 3 inches less than the length. Well, the length is going to be L minus 3. Finally, it tells us the perimeter is 26. So we need to know the perimeter formula for a rectangle. The perimeter is 26. So using our perimeter formula, P is equal to 2 times the quantity L plus W. We substitute in what we know, and what we know is that the perimeter is 26 equal to 2 times the quantity, the length plus the width. What we're going to do is we're going to substitute this L minus 3 in for the W. So we have an equation that has only one variable, and we can solve it. So in for the W, first I'm going to copy down the L plus now L minus 3. And I only put that in an extra set of parentheses for illustration purposes. You don't really need that second set of parentheses. So let's simplify what's in the parentheses. 26 is equal to 2 times the quantity, L plus L minus 3. Well, L plus L is 2L, and then minus 3. Now we have to distribute this 2 on the outside using the distributive property. 2 times 2L is 4L. 2 times minus 3 is minus 6. I bring down the 26 is equal to, now I'm running out of room, so I'm going to come up here. So I have 26 equal to 4L minus 6. Now I have to solve for L, and that's going to be adding 6 to both sides using the addition property of equality. 26 plus 6 is 32 equal to 4L. Then I'm going to divide each side by 4. The 4's divide out, leaving me 32 divided by 4, which is 8, equals to L, or the length is equal to 8. I'm not asked to find the length, though. It asks what is the width. And the width is equal to L minus 3. So the width is equal to 8 minus 3, which is equal to 5. So to answer the question, the width of the rectangle is 5. Here we have 2 different kinds of problems. Find 3 consecutive even integers whose sum is 60. I just read what's in the red. In the black, it says find 4 consecutive integers whose sum is 106. What I'd like you to do now is pause the video, write down, or actually first reread the problems to yourself, the problem on the left and the problem on the right. Write down everything you see that's similar and everything you see that's different. When you can't find any more similarities and differences, restart the video, come back, and compare what you wrote to what I wrote. Before the pause, I asked you to list out your similarities and differences that you could find in these two problems. The two similarities, though there are more exact similarities than I have here, it says finding consecutive integers. In both problems, we're asked to find consecutive integers. And in each problem, we are asked to find, or we are finding, a sum. How the problems are different and how they're similar is going to affect their setups, and we're going to see that in the next slide. But how they're different is in one problem we are finding 3 integers and we are finding 4 integers in the other problem. We're also finding in the first problem, in the red, we are finding consecutive even integers, and in the other problem we are just finding consecutive integers. And the actual sums are different. In the one problem, the sum is 60, and in the other problem, the sum is 106. So let's see how these similarities and differences affect our setups. Here in example 2t, we're solving the same two problems we just compared the similarities and differences of. So the first problem here in red is find 3 consecutive even integers whose sum is 60. And so we're looking for consecutive even integers. Here's the first set, or the smallest set, of even integers, just to give you an idea of what's going on. And what's going on here is that 2 is the first even integer. And to go from the first even integer to the second even integer, we have to add 2. And to go from the first even integer to the second even integer, we have to add 4. Now, it's just a coincidence because these numbers are small and it just happens to work that way, that the first 2 numbers are what we add. That's not generally the case. And in this problem, to set it up, we define our variables first based on the fact that we need to find 3 consecutive even integers. And we define our first variable, x, and that's equal to the first integer that we're going to find. The second integer, always we add 2. Well, the second even integer, we add 2 to the first integer. And that would be our second consecutive even integer. Thirdly, we have x plus 4, the first integer plus 4, the first even integer specifically. And we have to find their sum, so we have to add these 3 algebraic expressions up. 1x plus 1x plus 1x gives 3x. 2 plus 4 is 6. That gives us 3x plus 6. And that's our sum, 60. Now we have a very simple 2-step equation to solve. We are multiplying x by 3, and then we are adding 6. That's the do. So the undo would be subtract 6 from both sides. 6's on the left cancel, leaving us 3x equal to 54. 60 take away 6 is 54. Dividing each side by 3. X is equal to 18. Now, we want to find all 3 of those, and if the first number is 18, the second number is 20, and the third number is 22. So our 3 consecutive even integers whose sum is 60 are 18, 20, and 22. Now in this problem, we have to find 4 consecutive integers whose sum is 106. Now the difference between this problem and the first problem is the fact that we're finding 4, and we're only working with consecutive integers. Over here we were working with consecutive even integers. Here we're only working with consecutive integers. And in this case, the smallest set, well, the second smallest set of consecutive 4 integers would be 1, 2, 3, 4. Now to go from the first number to the second number, we add 1. To go from the first number to the second number, we add 2. And to go from the first number to the fourth number, we add 3. And this is going to work in our setup. The first number that we don't know is x, and that's going to be our first integer. The second integer, the second consecutive integer, is going to be x plus 1. The third integer is going to be x plus 2. And the fourth integer is going to be x plus 3. And since we're finding their sum, we have to add up these expressions. 1x plus 1x plus 1x plus 1x is 4x. And 1 plus 2 plus 3 is 6. So 4x plus 6, and that's equal to the sum that we have to find. 4 integers, 4 consecutive integers, 106. Now we have to solve this simple two-step equation. Since we're multiplying by 4 and then adding 6, we then have to undo 6 by subtracting 6 from both sides using the subtraction property. That leaves us with 4x is equal to 100. And we divide each side by 4 and get x is equal to 25. Now that's our first integer, 25. The next integer would be 26. The third integer would be 27. And the fourth integer is 28. So we can see how these problems are similar, but yet how they're different. Now, one thing I want to say is that even integer problems are the same as odd integer problems. So if you encounter an odd integer problem, they're set up the same way. X, x plus 2, and x plus 4. So go ahead and try your S examples and have those ready for class. In example 3T, it's the first time we're really talking about travel, or distance is equal to rate times time. We're talking about uniform motion here. And uniform motion has everything to do with the distance equation. Distance is equal to rate times time. This equation relates 3 different variables that are very useful when traveling. So here in example 3, we have an airplane left at airport flying at 180 miles per hour. So let's say this black plane down here is the airplane, or the first plane talked about in this problem. And then it says a plane that flies at 330 miles an hour left an hour later. So this plane started traveling later, but flies faster. So what we do about that, we're going to see, is adjust the time variable. So for the black plane, what we have is distance being equal to rate times time. And for the black plane, the rate is 180 miles per hour. We're just going to say it travels a specific or a certain amount of time. So the distance of the black plane is represented by 180 times t. The green plane, on the other hand, it's going to travel the same distance because we want to find how many hours it will take the plane to catch up with the airplane. So we want to find the time of this green plane. So the distance is equal to rate times time for the green plane. So the distance is going to be equal to its rate, which is 330 miles per hour. Now here's where we make the adjustment. This plane travels for 1 less hour. It starts 1 hour later. So it's going to be t minus 1. And since they're going to be traveling the same distance, we take this part and we set it equal to this part, and then we have an equation we can solve. So let's go ahead and do that. Let's actually write the equation we're going to solve. So in this case, the equation is going to be, and I'm going to put the parentheses on the left. It doesn't really matter where you put it, but it's going to be 330 times the quantity t minus 1 equal to 180t. And that's because we're trying to find the amount of time it's going to take these two planes to catch one another. So let's go ahead and solve this equation. To solve this equation, we have to distribute 330 first. So 330 times t is 330t. And 330 times minus 1 is minus 330. And that's equal to 180t. Now from here, we can go about it one of two ways. The way I would go about it is I would subtract 330t from both sides, because we do have variables on both sides. So we'll just subtract 330t from both sides. And that'll give us a negative on each side, which then will end up being a positive. Now, 180 take away 330 is going to be a negative 150. Be a negative 150t, and that's equal to negative 330. Then we divide each side by negative 150. When we do that, we can reduce or simplify this. This simplifies by dividing by a factor of 10, or we can just cancel those zeros and then divide negative 33 and negative 15 by a negative 3, which would give us 11 over 5. Negative 33 divided by negative 3 is equal to 11, and negative 15 divided by negative 3 is a positive 5. So t, the time, is equal to 11 over 5. And if we change that into a decimal, the time is going to be equal to 2.1 hours, or about 2 hours and 6 minutes. Now that's not the amount of time this plane in green's traveling. That's the amount of time this plane's traveling. So what we have to do is we have to take t, we have to subtract away 1 from it. So that would give us 2.1 minus 1, 2.1 hours minus 1 hour, and that would be equal to 1.1 hours, or about 1 hour and 6 minutes. That's how long it's going to take this green plane to catch up with the black plane. So in example 4t, we move away from same direction travel where the two objects or people were going in the same direction. In this case, we have a round trip travel where you go from a starting point to an end point and you go back round again, come back to where you started. Suppose you hike up a hill at 4 kilometers per hour. You hike back down at 6 kilometers per hour. Your hiking trip took 3 hours. How long was your trip up the hill? So in this case, we're trying to find the amount of time the trip up the hill took, and we're given our speeds or our rates, and we are given our total hours, 3. So let's see how that works out for us. Now, I'm going to set this up a little bit different. In this case, we're going to go our trip up the hill and our trip down the hill. And this is more in the lines of a table. And the rate and the time, and then we'll have over here a column for distance. Now, the rate up the hill was 4 kilometers per hour, and the rate down the hill was 6 kilometers per hour. There's our rates right there. Now it tells us our hiking trip took 3 hours. So our hiking trip took 3 hours. So the time here, if we call the time here t, the second time is going to be 3 hours minus t. However long the trip up the hill is, we know we're going to take that time and subtract it from 3 because the whole trip was 3 hours. Now our distances are going to be represented by the multiplication of the rate and the time. So we have to multiply 4 times t, and that just gives us 4t. And in this case we have to go 6 times 3t, which is going to give us 18 minus 6t. I distributed that already, so there's a way you can save yourself some time when it comes to solving the equation. When you write your distance, you can distribute that 6 instead of writing it as 6 times the quantity 3 minus t, because we know the distances are going to be the same. We're going up the hill to a point, and we're turning around and coming back down. So the distances are going to be the same. So we set these two things equal to each other to make our equation, then we solve our equation. And our equation would be 4t equal to 18 minus 6t. Now, I think the best way to go about solving this problem would be, this equation would be solving 6t to each side. Not solving, but adding 6t to each side. The 6t's on the left cancel. 4t plus 6t is 10t. And that's equal to 18. Divide each side by 10. And that gives us t, the time being, equal to 1.8 hours. And of course, t represents our time going up the hill, so t is equal to 1.8 hours. Now, if we wanted to express that in hours and minutes, that wouldn't be 1 hour 8 minutes. That'd be 1 hour and 48 minutes. And the reason we get 48 minutes is these are 8/10 of an hour, and 1/10 of an hour is 6 minutes. So if we take 8 and multiply it by 6, that gives us 48. So the trip uphill was 1.8 hours, or 1 hour and 48 minutes. In example 5t, we continue our work with uniform motion. And in this problem, we're going to be talking about opposite direction travel. Remember, we're working with distance is equal to rate times time. Here we're told that two jets leave Dallas at the same time and fly in opposite directions. So set that up with a little simple diagram. Planes start at this dot, one goes this way, one goes that way, opposite direction travel. One is flying west, 50 miles per hour faster than the other. So if we assume up is north, this would be west. So we know the plane going this way is going faster than the plane going east. After 2 hours, they are 2,500 miles apart. Find the speed of each jet. So our objective here is to find the speed, or find the rate, in distance is equal to rate times time. This sentence here lays out the variable for us. One is flying west 50 miles per hour faster than the other. So let's start working with the distance is equal to rate times time for the plane traveling east. We're going to be working with their distances in a minute, but their distance is going to be expressed with a variable expression. We're told that the planes are traveling 2 miles for 2 hours. We have to multiply that by the rate. We don't know the rate of the plane going east, but we do know the rate of the plane going west is 50 more than this. So for the plane over here, this plane, we're simply going to say the distance is equal to 2 times r. 2 times the speed of this plane. Here, in distance is equal to rate times time. The time is 2 hours, but the rate is going to be 50 miles per hour faster than the rate of the plane going east. And what we have to do is we have to add these two distances, 2 times the quantity r plus 50 plus 2 times r, and that's going to be equal to 2,500 miles apart. They start at the same place and go in opposite directions, and this is how we represent the distance they travel. This one's going to travel a little bit further. In fact, it's going to travel 50 miles further. So let's see how this works out. That would give us the equation. I'm going to do this equation over here. 2 times the quantity r plus 50 plus 2 times r, 2r, and that has to be equal to how far apart they are. I've seen some textbooks go as far as saying this is d sub 1, the distance of the first plane, and this is d sub 2, the distance of the second plane, and giving these sub-variables. Don't need to worry about all that. As long as you understand this is the distance of the first plane, this is the distance of the second plane, and this is the total distance they're going to be after 2 hours, how far apart they're going to be after 2 hours of travel. So we solve this equation by distributing. 2 times r is 2r, 2 times 50 is 100. Bring down the plus 2r and equals 2,500. On the left-hand side, I have to combine these like terms. I have to add them together. 2r plus 2r is 4r, and that'd be plus 100 is equal to 2,500. I subtract 100 from both sides using the subtraction property of equality, leaving 4r on the left. Remember, these cancel. That's going to be equal to 2,400. dividing each side by 4. The rate of the plane going east is 600 miles per hour. We need to find the speed of each jet. Well, so the speed of the other jet is r plus 50. The rate of this plane going east plus 50, so that would give us 650 miles per hour. So the plane going west is traveling at 650 miles per hour, and the train going east is traveling at 600 miles per hour.